derivative, instantaneous rate of change at a point. We want to find the slope of a curve at x equals to a. So right off the bat, slope has multiple names in calculus. You can call that slope, you can call that derivative, you can call that instantaneous rate of change, or you can just simply call that rate of change. So for rate of change, sometimes we just go by ROC, rate of change. Again, so multiple names: slope, derivative, rate of change. So we have a curve f of x. So take a look at the graph I gave you. So we have a f of x. So this is a curve, and then the way we do this is we want to start with a secant line, so which is the orange line. So for secant line means we have to sketch a straight line that crosses the curve twice. So secant line has two intersections. The first point is at a. So when x is equals to a, we have f of a, so that is the first point. And then the next point is you take h steps forward. So starting at a, and then you plus h step. So you from a, you reach to a plus h, and then the corresponding y value is f of a plus h. You plug in a plus h to f of x to obtain the y value. So we have 2 points, one at x equals to a, and one at a x equals to a plus h. All right, and then we sketch a straight line that intersects, that crosses these 2 points. So we have a straight line, so we have two intersections, one at a and then one at a plus h. So this is a straight line. Forget about the curve for a minute. What is the slope of a straight line? So the slope of a straight line, we will just go by y2 minus y1 divided by x2 minus x1, which is rise over run. So in terms of this graph, the second point is a plus h, right? F of a plus h minus f of a, so that is y2 minus y1, and then divided by x2 minus x1, which is a plus h minus a. So you don't simplify anything yet. So we have y2 minus y1 divided by x2 minus x1, and then this is rise over run. Okay, so now we have a secant line, two intersections, and then we find the slope of this secant line using rise over run. And then the next step is very important, which is a core concept in this lesson, is we have to shrink h, and then that means we have to let x goes to 0. Why do we do this? The purpose of this problem is I am trying to find the slope of the curve at x equals to a at 1 point only. I am not asking for 2 points. I am asking for 1 point only. When x is equals to a, what is the slope of the curve? All right, but since for curve we have 1 point, so having 1 point is not enough to do the rise over run. So that means we have to start with 2 points, and then we shrink the distance between these 2 points to get to 1 point. So we start at 2, shrink the distance, and then we reach from 2 points to 1 point. So here is the picture. So let me change the color to that, and then I want to make the line bold. So here is how we are going to do it. So we have a point, right? So we have a point right over here. And then we have another point at a plus h. So we have a line that looks like this. So do you follow this? We have a line that looks like this. Follow the big circle, right? We have 2 points. How do we shrink it? So as h goes to 0, so we want to move the second point close to the first point. So as x goes to 0, here is the picture. So as h goes to 0, the distance between these 2 points is shrinking along the curve. So let's do this one more time. This is at the very beginning. As h goes to 0, shrinking. So once h goes to 0, do we agree that we just go back to point A? And then at this point, there is a tangent line. So there is a tangent line at this point. The tangent line looks like this. The tangent line is also a straight line, but the tangent line only touches the curve at 1 point. Okay, the tangent line is a straight line touching f at x equals to a. So the slope of this tangent line is the slope of the curve at point A. So once again, a tangent line is a straight line touching f of x at point A. So the slope of the tangent line is equals to the slope of the curve at x equals to a. So since we have to let x goes to 0, then we have to set up a limit. So we started from this, and then the first step that we will have to do is we simplify the denominator. A plus h minus a is equals to h, and then we let h goes to 0. So therefore we have a limit right over there. And then this is the limit definition of derivative at x equals to a. Again, the limit definition of derivative at x equals to a. For this limit, you can call this is simply equals to f prime at a. So f prime at a, the derivative of the function at x equals to a, and this is called the limit definition. And then the tangent line is a linear function. We are trying to use the slope of the straight line to estimate the slope of the curve at x equals to a. So let's do a quick example. The quick example I have right over here is I have a parabola, and then I want to find f prime of a. So that means I am looking for the slope of the parabola when x is equals to 3 and x is equals to negative 3. So let's take care of the 3 first. I'm going to follow the color. So let's take care of the 3. So first of all, when a is equals to 3, we plug in the a to the function. 3 squared is equals to 9, and then we get a point, and then we follow the limit definition of derivative. So this is called f prime at a equals to 3, and then the next line, we have limit as h goes to 0. So we have to change the x to a plus h. Then we have 3 plus h squared, and then minus f of 3. So that is equals to 9, right? So this 9 goes right over here. So that is equals to 9 because we are subtracting f of 3. And then we divide it by h. So when you solve this kind of limit, fully expand the numerator and then cancel as many terms as possible. So we have limit as h goes to 0. So the numerator, we open up the square, we have 9 plus 6h plus h squared, and then minus 9 divided by h. And then as you can see, the 9 and the minus 9 got cancelled, and then you factor out 1h to get rid of the h in the denominator. So factor out 1h, and then you have 6h plus, not 6h, and then you have 6 plus h divided by h, and then you get rid of the h once h goes to 0. So you have a 6, right? So this 6, what is this called? This is called the slope of the tangent line to x squared. So slope of the tangent line to the parabola at x equals to 3. So when x is equals to 3, do you see that on the right hand side of the curve? Do you see that when x is equals to 3? So when x is equals to 3, there is a point on the parabola. At that point, the slope is equals to 6. And then there is a tangent line, y equals to 6x minus 9. How do we get that? So let me bring you to that point right now. So in order to build a straight line, we have a point, we have a slope, right? So the slope is equals to 6. In algebra, the slope we call it m, and then the point we have when x is equals to 3, 3 squared is equals to 9. That is a point on the parabola. And then to build the tangent line, we have to use a point slope form. Y minus y1 equals to slope times x minus x1. This is called point slope form. You learned that in elementary algebra and review that in pre-calculus. And then y minus 9 equals to slope times x minus 3. So you have y minus 9 equals to 6x minus 18, right? And then minus 18, you add 9 to it, then y is equals to 6x. Negative 18 plus 9 is equals to negative 9. And then what is this called? This is called the equation of the tangent line. So equation of the tangent line to the parabola at x equals to 3. So the picture is we have a parabola like that, and then at this point, this is a tangent line. What is the slope? What is the equation of the tangent line? Y equals to 6x minus 9, and then the slope is equals to 6. So that means when x is equals to 3, the slope of the parabola at this point is equals to 6. Okay, so how about negative 3? How about a equals to negative 3? So for a equals to negative 3, let's use a different color to divide this up. So when a is equals to negative 3, so when a is equals to negative 3, f of negative 3 is negative 3 squared, right? So equals to 9. And then the points we have is x equals to negative 3, y is equals to 9. And then we do the limit definition of derivative. So f prime at negative 3, that is equals to limit as h goes to 0, f of a plus h. So a plus h, the limit definition right over there. So a plus h, this is a negative 3 plus h minus the function at negative 3. And then you divide it by h, limit as h goes to 0. You change the x to negative 3 plus h, and then square minus, this is a 9, right? You plug in negative 3, you get a 9, and then divided by h, fully open up the numerator. You have limit as h goes to 0, negative 3 times negative 3, so that is 9 minus 6h squared plus h squared minus 9 divided by h, and then you can see that the 9 and the negative 9 got cancelled. So now you factor out h, so you have limit as h goes to 0. You factor out 1h, and then you have negative 6 plus, I wrote a square, the square is not right, plus h divided by h, and then you get rid of the h, and then what do you see? When h goes to 0, we have a negative 6. So this is the slope of the tangent line. Without having the equation of the tangent line, I can tell that for parabola, when x is equals to negative 3, the slope of the parabola is negative 6. And then to find the tangent line, we do y minus y1 equals to slope times x minus x1. The point is y minus 9 equals to negative 6, and then x minus negative 3. And then this one gives you y equals to negative 6x minus 9. And then this is equation of the tangent line. Let's draw a picture. We have a parabola. So we have a parabola that looks like this. When x is equals to negative 3, we have a point right over here. So this is negative 3 comma 9 for the x squared. All right. I am looking for the slope of the parabola at this point, and then the slope after using the limit definition of derivative, we know that the slope is equals to negative 6. That is called the slope. Is equals to negative 6, and then this straight line is the tangent line. The equation of this tangent line is y equals to negative 6x minus 9, which is exactly what I have right over here. All right, so that's it for this video. If you like it, you think this is helpful, give me a like, share, and subscribe, and I will see you all in the next one. Signing out.